Let's continue with compounds of boron. Diborane is the next, B2H6. The simplest boron hydride is called diborane. Simple formula is BH3, but because it is electron deficient, that's why it exists as dimer. It is prepared by treating boron fluoride or boron halide with lithium aluminium hydride, which acts as reducing agent. We will get B2H6 plus lithium fluoride plus aluminium fluoride will be formed. So 4BF3 plus 3 LiAlH4 gives 2B2H6 plus 3 LiF and 3 aluminium fluoride are formed. Diethyl ether is used as a solvent so that reaction takes place faster. Another method for preparation of diborane is if we react sodium borohydride with hydrogen, we'll get B2H6. Iodine will get reduced to iodide ion by gaining electron. So iodine here it is acting as oxidizing agent because it's gaining electron to iodide ion, whereas sodium borohydride is acting as reducing agent. We get B2H6 plus hydrogen is generated. So hydride ion are changing to hydrogen by loss of electrons, whereas iodine is changing to iodide ion by gain of electrons, so it is redox reaction. Diborane is also produced on industrial scale by the reaction of BF3 with sodium hydride. Here sodium hydride is acting as reducing agent. Reaction takes place around 450 Kelvin. Diborane B2H6 is formed plus sodium fluoride is formed. Diborane is colorless, highly toxic gas with boiling point of 180 Kelvin. It catches fire spontaneously upon exposure to air. It burns in oxygen, releasing an enormous amount of energy. So B2H6 plus 3O2 gives you B2O3 plus 3 water, and energy liberated is 1976 kilojoules per mole. So it's highly combustible and high amount of energy is released on its combustion. Most of the higher boranes are also spontaneously inflammable in air. Boranes are readily hydrolyzed by water, giving boric acid. B2H6 reacts with 6 moles of water to give 2 moles of boric acid plus 6 hydrogen is formed. Diborane undergoes cleavage reaction with Lewis acid to form borane adducts, that is coordination compounds, because it acts as a Lewis acid and it will react with Lewis base to form coordinate compounds or addition compounds. They are also called adducts. For example, B2H6 reacts with trimethylamine, Ame stands for methyl group, trimethylamine, which is a Lewis base, and they form a addition compound or coordination compound. Similarly, B2H6 reacts with 2 moles of carbon monoxide to form this addition or coordination compound between them. Here carbon monoxide has lone pair of electron which is sharing with BH3 so that its octet is complete. Here trimethylamine was having lone pair of electron which is forming coordinate bond with BH3 so that its octet is complete by sharing of electrons. Reaction of ammonia with diborane is very important. B2H6 reacts with ammonia to first give this intermediate and finally it gives B3N3H6. Structure is similar to benzene, that's why it is also called inorganic benzene. Plus 12 moles of hydrogen are formed. This is called borazole, borazine or inorganic benzene. This is the structure of borazole. It is similar to benzene. Here boron and nitrogen have alternate position and each of them is linked with one hydrogen atom, and instead of double bond there is a coordinate bond starting from nitrogen to boron. In 3 nitrogen atoms are there, all the 3 are forming coordinate bond with boron so that octet of boron is complete and its structure is similar to benzene. That's why it is called inorganic benzene. It's also called borazine or borazole. The structure of diborane has 4 terminal hydrogen atoms and these are 4 terminal hydrogen atoms, 1, 2, 3, 4. Above and the 2 boron atoms lie in one plane. These 2 boron atoms lie in one plane because outer bond angle is 120. Here also it is 120. Above and below this plane there are 2 bridging hydrogen atoms. This is hydrogen bridge, this is hydrogen bridge, which have 3 centered bond. This one is 3 centered bond and this one is also 3 centered bond. So there are 2 3 centered bond. They are also called banana bond or bridged bond. This bond length is 134 picometer, which is longer due to weak bond. This bond length is 119 picometer, which is shorter due to strong covalent bond. This angle is 97 degree. This is orbital overlapping of diborane, and this is representing a banana bond in between, which are bridged bonds. This angle is 120, this angle is 120. Bonding in diborane, each boron atom uses sp3 hybridized for bonding. Out of the 4 sp3 hybridized on each boron atom, one is without an electron, which is shown by broken lines. So an empty orbital combines with boron and overlaps to form hydrogen bridges. Boron forms a series of borohydrides or hydridoborates. The most important one is tetrahedral BH4 minus ion. Tetrahydridoborates of several metals are known. Lithium and sodium tetrahydridoborates are also known as borohydrides. They are prepared by reaction of metal hydrides with diborane in a diethyl ether as a solvent. 2MH means sodium hydride, lithium hydride will react with B2H6 to form sodium borohydride or lithium borohydride. So metal is lithium or sodium. Both lithium borohydride and sodium borohydride are used as reducing agents in organic synthesis. They are useful starting material for the preparation of other metal borohydrides. Oxides and hydroxides. B2O3 being acidic oxide will react with base and basic oxide to form salts. So 2NaOH plus B2O3 will react to form sodium metaborate plus water is formed. Copper oxide will react with B2O3 to form copper metaborate, which is blue in color. Cobalt oxide will react with B2O3 to form cobalt metaborate, which is blue in color. This copper metaborate on reduction will give reddish brown copper from which it can be identified, whereas cobalt metaborate will be blue in color. Aluminium trioxide being amphoteric in nature will react with base as well as acid. When it reacts with HCl, it forms 2AlCl3 plus 3 water. Al2O3 reacts with 2NaOH to form sodium metaaluminate plus water. These two reactions prove that Al2O3 is amphoteric in nature. Gallium trioxide also is amphoteric in nature. It forms with 2NaOH, it forms sodium metagallate plus water is formed. So boric acid is acidic, aluminium hydroxide and gallium hydroxide are amphoteric in nature, whereas indium and thallium hydroxides are basic in nature. BCl3, BBr3, Bi3 all on hydrolysis will give boric acid plus 3HCl, 3HBr and 3HI respectively will be formed.